Welcome to part 3 of the dimensional analysis topic. In this video, we'll solve 3 problems for which we'll need to perform multi-step unit conversions. Here's example number 1. A doctor's order prescribed a dosage of 0.150 milligrams of Synthroid. If tablets in stock contain 75 micrograms of Synthroid, how many tablets are required to provide the prescribed medication? As always, we will start by providing information for the given measured amount and its units, and we're going to make a note of the units that we need to convert to. In this problem, it states that a prescribed dosage is 0.150 milligrams. We write it as a given measurement. And the question is, what is that prescribed dosage but in tablets? How many tablets are required to provide the prescribed medication? This means we need to convert milligrams to tablets. As you already know from the previous video, we convert from one unit to another using conversion factors. Some conversion factors can be obtained from the information given within the problem, and others we can obtain from the tables of units. Notice in this problem we do have some information that we haven't used yet. It says that tablets in stock contain 75 micrograms of Synthroid. So this is something that we can use to obtain a conversion factor. From this information, we can write an equality. One tablet equals to 75 micrograms of the drug. And from this equality, we can obtain 2 conversion factors. Which one will be useful to us? Recall that the approach we take is canceling the units that we don't need and leaving the desired units. My goal is to cancel units milligrams and be left with units tablets. I notice that the conversion factors that I have here don't involve milligrams, which means that I won't be able to cancel milligrams using these conversion factors. However, these conversion factors have units that I want to be left with, tablets. All of this means that I won't be able to perform conversion using just one step, and I will have to perform 2 or more steps. So at this point, my goal is not just to decide which one out of these 2 conversion factors to use, but also where to place it in the multiplication operation that I'll have to perform. Once again, since these conversion factors do not have the given units, but do have the desired units, I'm going to choose the one that has tablets in the numerator, because that's where my desired units have to be at the end. And I'm going to place this conversion factor as the last step, right next to my future final answer. Next, my goal is to find a way to cancel milligrams and micrograms. I am recognizing that these are metric units related to grams, where one has prefix milli and another one has prefix micro. I'm going to look at the table of metric unit prefixes to see how it can help. Again, in my problem I have milligrams and micrograms. This table reminds me that prefix milli represents a small quantity, specifically thousandth. So instead of prefix milli, I can use numerical value 1000th, or I could also write it as 10 to the power negative 3. And this allows me to create an equality or relationship between milligrams and grams. This table also reminds me that prefix micro also represents a small value that represents 1 millionth, or 10 to the power negative 6. So I'm going to replace prefix micro with numerical value 1 millionth, and this is another equality or equivalent statement. From these equalities, I am able to create 2 conversion factors for each. Let's take these conversion factors back to our problem and think which ones will be helpful to us. I'm going to remind myself that my goal is to cancel the given units and be left with the desired units. The given units are milligrams, and now I have conversion factors that involve milligrams. Out of these 2 conversion factors, I will choose the one that has milligrams in the denominator, since that will allow me to cancel the like units. So that's where I'm going to write this conversion factor, and this is how I'm going to cancel like units. Now I am left with grams in the numerator and then micrograms in the denominator. While I do have conversion factors that involve both units, which one do I need to choose? Again, my goal to cancel grams as well as to cancel micrograms. Since grams that I have are in the numerator, I want to choose the conversion factor that has grams in the denominator. That must be this one. In addition, I can see how this conversion factor has micrograms in the numerator. Well, this will allow me to cancel micrograms that I have here. I've placed my conversion factor here in the chain of steps that I'm creating. Now I can cancel grams, and I can cancel micrograms, and I can see that I'm left with the right units, tablets. What's left to do is to perform computation. Let's recall that we multiply by the numbers written in the numerator, and we divide by the numbers written in the denominator. And also ones can always be ignored, they don't change the answer. So to perform this computation on the calculator, I go in order. I start with the first number, 0.150. Then since next fraction has number in the numerator, I will multiply by it times 0.001. Here it is. Now since next fraction has number in the denominator, I will divide by that number. Divide by 1/1,000,000th. And then since next fraction also has a number in the denominator, I will also divide by it. Divide by 75. And that equals to 2, which is my final answer. That's why I record it. As always, at the end, I check if my answer makes sense. And in this case, the prescribed dosage of 2 tablets of medication does sound reasonable. Let's try example number 2. The rate of water flow into a bathtub was 1.3 times 10 to the third power milliliters per minute. How many minutes would it take to fill the bathtub with 51 gallons of water? Round the answer to 5 digits. Let's start by writing down what's given and what we need to find. The question is asking how many minutes, so these are the units we need to find, would it take to fill the bathtub with 51 gallons of water. So that's what we're starting with, 51 gallons of water. Next, we'll need to obtain conversion factors that will allow us to convert from gallons to minutes. One of the conversion factors can be obtained from the information given in the problem. The first sentence states that the rate of water flow into a bathtub was 1.30 times 10 to the third power milliliters per minute. Notice how this phrase involves 2 different units, milliliters and minute. So that is an equality or equivalent statement hidden within this phrase. This is how we can write it down mathematically. This amount of water is flown each minute. And from this given equality, we can obtain the following 2 conversion factors. Which one do we choose and where do we place it within our multiplication steps here? Remember our goal to cancel gallons and to be left with minutes. There are no gallons in the conversion factors that we have, but they do contain minutes. Since I want to be left with minutes, I'm going to choose the conversion factor that has minutes in the numerator. And I place it right at the end, next to my future final answer. Now I need to find a way to cancel gallons and milliliters. In other words, I have to find conversion factors that involve both of them. It can be one or few. An additional observation that I can make is that gallons are English units and milliliters are metric units. That means that I need to take a table that gives me the relationship between English and metric units. Here it is. Milliliters and gallons are units of volume. As I look at the metric English relationships between the units of volume, I don't see any that relate milliliters and gallons. But I do see one that relates milliliters and quarts. And next, as I look at the relationships between English units of volume, I see one that relates quarts and gallons. And I can see how I can connect them. Milliliters are related to quarts, and then quarts are related to gallons. That will work. So for each of those 2 qualities, I can create 2 conversion factors. Let's copy them to our problem and decide which ones will be useful. I'll go in order. The given units, gallons, have to be cancelled. So I have to choose a conversion factor that has gallons in the denominator. It must be this one. I've copied it to my problem and can go ahead and cancel gallons. Now I'm left with quarts and milliliters. I want to cancel both. Quarts are in the numerator here, so I want to choose a conversion factor that has quarts in the denominator. Milliliters are in the denominator, so I want to choose a conversion factor that has milliliters in the numerator. So that must be this one. I've copied it to my problem as well. And now I can finish off canceling like units. Quarts get cancelled, and milliliters get cancelled. I am left with minutes, and these are the desired units. What's left to do just to perform computations? So it's easier for me to enter this number given in the scientific notation. I'm going to rewrite it in standard form. 10 to the power 3, I'll rewrite as 1000. Remember, power tells me the number of zeros I should have in the number. And then after multiplying 1.3 by 1000, I get 1300. That's the number I'll use for computation. As always, I'm going in order of fractions, ignoring ones. I start with 51. Next number is in the numerator, so I multiply by it, times 4. Number in the next fraction is also in the numerator, 946. I multiply by it. And in the next fraction, I have number in the denominator. That's the one that's now written as 1300. So I will be dividing by that number since it's in the denominator. These are my operations shown on the calculator, and that's the answer. The problem required to round the answer to 5 digits. I'm gonna count 5. 1, 2, 3, 4, 5. Digit 9 in the following digits I will drop. However, because the first digit that I drop is 9, I will need to round the number up. So instead of 4, my last digit will become 5. I increased by 1. So my answer will be 148.45. I'm going to copy that answer. Here it is. According to our answer, it's going to take 148.45 minutes to fill the bathtub with 51 gallons of water. Does this answer make sense? It does. 148 minutes is about 2.5 hours, so that sounds pretty reasonable. Let's try our last example, example 3. In this example, we are provided with 3 equalities that establish relationships between different chemical compounds. They're denoted by different formulas, as you can see. It's important to look a little closer at those equalities and to notice differences and similarities. Notice that there is an equality that relates different compounds, and there are 2 equalities that relate same compounds. Also notice that the units used in the equalities are different. For one, the units are moles on both sides, but for the others, it's moles versus grams. All that is important because the provided equalities will allow us to obtain conversion factors, and it's important to use them correctly. Well, let's read the question. It says, determine the mass in grams of H2O2 if you had 6.023 grams of this chemical compound. The good part is it's not even important at this point to know its name, but I believe it's called potassium permanganate. As always, let's start by listing what's given and what we need to find. We're given 6.023 grams of this compound, which is potassium permanganate, and we need to find the mass in grams, so I'm noting the unit grams, of H2O2. I believe it's hydrogen peroxide. So for this kind of conversion problems, it's not only important to be left with the right units, grams in this case, but also with the right chemical formula. How will we approach this problem? Well, as before, we need to obtain conversion factors. Conversion factors we get from equalities or equivalent statements, and the good news is that we do have 3 of them. Let's set up conversion factors for each and see which ones will be useful for us. Here they are. For each of the given equalities, I set up 2 conversion factors. And for this problem, it will make sense to go in order. I have to know the given units and the given chemical formula. My goal will be to cancel what's given. So I'll need to choose a conversion factor that will have same units and the same chemical formula in the denominator. And if you look at all of them, the only one that works is this one. Grams in the denominator and the same chemical formula. So this is where I place the chosen conversion factor. And now I can cancel like units, grams, and the like chemical formulas. And I'll keep going, because I still don't have desired units and desired chemical formula. This is what I need. So I need to find a conversion factor that will cancel the units, moles, and this chemical formula. Which one is it? As I look through all the conversion factors listed here, I actually see 2 of them that match my description. This one here, it has moles and the right formula in the denominator. And this one, it also has moles and the desired formula in the denominator. Which one do I choose? Well, the rule is that I should never use the conversion factor or its equivalent ratio that I've used before. Remember how I've used this one. So it means that I'm no longer allowed to use its equivalent conversion factor. Otherwise, they just negate or cancel each other. So the one I'll choose is this one here. I've copied down here to my multiplication steps. And now we can see how like units, moles, can be cancelled, and the same chemical formula can be cancelled. At this point, I can check if I'm done or not, but I can see that while I have the right chemical formula, that's what I want to end up with, the units are not correct. So I will need to use another conversion factor. To cancel moles and the chemical formula, I'm going to use this conversion factor. I can see how it has the right units and the right chemical formula in the denominator. And besides that, it has the right units or desired units and the desired chemical formula in the numerator. I copied this conversion factor in my multiplication steps. And now I can cancel like units and the same chemical formulas. What I'm left with is the desired units, grams, and the desired chemical formula. What's left to do is to perform computations. As always, I ignore ones and start with the first number, 6.023. In the next fraction, I have number in the denominator, so I will need to divide by it. Divide by 158.036. Next fraction has numbers both in the numerator and the denominator. I will need to multiply by 5 and then divide by 2. By the way, it doesn't matter in which order I do that. I can divide first and then multiply, but I chose to start with multiplication. So times 5, divide by 2. And the last fraction has number in the numerator, so I need to multiply by it. Times 34.02. I hit equal sign and I get my answer. The problem requires to round answers to 5 digits. I count 5, 1, 2, 3, 4, 5, 8, and everything beyond will have to be dropped. Since 8 is the first digit to drop and it's more than 5, I will need to round my number up. So instead of 3, in the answer, I'm going to put 4. So the answer is 3.2414 grams. And I record my answer here.